Hi, and welcome back to Chemistry 1032 Lab Prelab videos. I am your host, Dr. Russell Betts, and today we'll be talking about chemical reactions. You've waited for it, you've longed for it, and here it is, chemistry reactions. It's going to be great. Part 1, we'll be doing reactions with metals. I'll be doing that one for you as a video experiment. In Part 2, we'll do reactions with aqueous solutions. Again, I'll be doing that one for you. Don't worry, there's lots you can do at home. But these ones I'll do for you in the video because it can be slightly dangerous and slightly expensive. Reaction with aqueous solutions is pretty fun. See a lot of color changes and things like that. Part 3, we'll do some reactions with acids and bases, and we'll see what happens there. In Part 4, vinegar and baking soda, classic science high school science club experiment or high school science fair experiment. It's also called the volcano reaction. Part 5, we'll be throwing some eggshells in with vinegar and seeing what happens. And in Part 6, you'll be making a solid using some very simple, basic items you can get at the grocery store. Pretty cool stuff. Before we get into the parts of the experiment, we need to discuss a few things to make sure we're all on the same page. To identify if a reaction has occurred, there's a few things you need to look for. The most subtle of all the things you look for is heat. Does the heat change? Does it get warmer? Does it get colder? You've all seen these things that if you sprain your ankle, they might take a pack and break the inside bag and shake it real hard, slap it on your ankle. Well, there's a chemical reaction occurring that's making the reaction get cold. If you live in the north, like I did, you had these things called heat pads where you take the similar idea, you take a package and you rub it in your hands like that, and it would force two chemicals to rub together, and they'd have a chemical reaction to generate heat. Solid production. If two liquids combine to make a solid, that's a chemical reaction that's occurred. Production of gas. You've seen this one before. Whenever, carbonate or bicarbonate combine with some kind of acid, they make gas. Color changes. Probably the coolest part of chemistry that everyone loves to talk about is color change. When two clear liquids react to give you a bright red color, something chemical has happened there. Pretty cool stuff. Reading chemical equations. You have to know how to read these things. Very simple. Here's a basic chemical reaction. Here are the symbols of the reactants. The things on the left-hand side of the arrow are the reactants, and here are their symbols. In this particular reaction, it's carbon reacting with oxygen. Notice the designator here. C with a subscripted F in parentheses means carbon solid. So it's solid carbon. It's a state of matter. Solid carbon. G, gas, so it's oxygen in the gas state. On the right-hand side of the arrow, these are the products. And this particular reaction generates CO2 gas. And here are what all the designators mean. We haven't used them all in this example. S is solid, G is gas, L is liquid, and AQ stands for aqueous, which simply means dissolved in water. Balancing equations. Now, in this experiment, you're going to have to do quite a bit of balancing. It's not hard. Sometimes students find this to be a little challenging, but really it's not. Think of it more as a game or a puzzle. Okay? Don't think of it as anything challenging. Think of it as something that's challenging and fun. You really want to do it because it's easy. So how I tell students to start. Now, if you have your own way and you can already balance equations, my way, you don't need to do it because you have your own way that works for you and you're doing fine with it. But if you're starting out, you might want to start doing it my way. I have a bookkeeping method. I like to keep things straight. So what I do is I take the reactants, every atom on the left-hand side of the arrow essentially, and I write down what they are. Magnesium and oxygen. And then I count them. On the left-hand side of the arrow, how many magnesium do I have? Well, I have 1. On the left-hand side, I have 2. Oxygen. See? 1 here. Multiply by the 1 there. Remember, there's an imaginary 1 here and here. It's not drawn in, but just like in mathematics, the 1s are assumed. Okay? Let's get rid of those things. So here, imaginary 1 multiplied by 2 gives me 2. Let's come over here. Now remember, there's an imaginary 1 here, and in this formula, there's an imaginary 1 here and an imaginary 1 there. They're not drawn in. They're just assumed to be there because there's no other number. Just like in math, you always assume the 1. So the imaginary 1 multiplied by an imaginary 1, so there's 1 magnesium on the right and 1 oxygen. Okay, that's how many atoms we have on the left. That's how many atoms we have on the right. And you can see the oxygens are not balanced. That's okay. We can balance them because we are awesome. The only thing you're allowed to do, however, is change the number in front, called the coefficient. At this moment right now, there's nothing written above these lines I've just drawn. There's nothing written above these blanks. There's no coefficient written. So you assume it's 1. Okay? Now we can change the coefficient to any whole number we want. But we're trying to balance the equation. We're trying to make the magnesium on the left equal the magnesium on the right. So how do we do that? Well, it's already balanced. We're trying to make the oxygen on the left equal the oxygen on the right. How do we do that? Well, simple. We put the number 2 right there. We change the 1, the coefficient in front of the magnesium oxide, to a 2. That changes this to a 2 and changes this to a 2. Because remember, this multiplies by the imaginary 1 here and here. So this becomes 2. That's okay, because now the oxygens are now balanced, right? But the magnesiums are out of balance. And that's okay, so we can fix that too. Simply come over here to the left-hand side and put the number 2. Okay? And this is now balanced. Let's be careful. Let's double check. Let's always double check. 2 magnesium, 2 times 1, 2 magnesium. 1 times 2 oxygen, 2 times 1 oxygen. Okay? Now I left this blank. You can put a 1 there if you want. You're not supposed to, but if you do, I'd mark it right on an exam. By convention, you just leave it blank, and people assume it's a 1. Another example, a little bit harder example, more atoms involved. Really not that bad. Let's do some bookkeeping. Carbon, hydrogen, oxygen. On the left-hand side, we have 3 carbon from here, 8 hydrogen, and 2. On the right-hand side, we have 1 carbon, 2 hydrogen, and oxygen. You have to be careful with oxygen, because notice it's in this compound. It's also in this compound. It's in the carbon dioxide, and it's in the water. So you've got to account for it from both places. Doesn't matter that it's in 2 different molecules. What matters is that it's on the right-hand side of the arrow. 2 plus 1 is 3. So 3 oxygens on the right. No problem. Carbon's not balanced, hydrogen's not balanced, and oxygen's not balanced. So everything's out of balance. Here's a hint. Notice how you have O2 here by itself. That's what I call that a standalone element. It's just there by itself. Any coefficient we put here is only going to affect oxygen on the left. It's not going to affect anybody else. So why don't we just wait till the end to use it? Why don't we figure out how many oxygens are on the right and then just put the number here and make whatever number multiplied by 2 to make the number that's over here. In other words, leave it to the end. Leave the standalone elements till the end. It almost always makes your life easier. All right, so on the right-hand side, on the left-hand side, we have 3 carbons. On the right, we have 1. Let's make it 3. Why not? Just make it 3, because you have to have 3 carbons on the right. You have them on the left, you've got to have them on the right. Go through the math. Go through everything again. 3 times 1 carbon is 3 carbons. So the carbons are now balanced, but that may change. Keep that open mind. 3 times 2 oxygen is 6, plus 1 is 7. The oxygens are increasing. We have 7 now. That's okay. Just keep doing the math. 2 hydrogens, and that's it. Okay, so carbons are balanced. Hydrogens are not. So we got to balance them. Well, we have 8 over here on the left. We need to have 8 over here on the right. And 2 times 4 is 8. So let's put a 4 in front. All right, let's count again. 3 carbons, 6 plus, oh, wait now. 6 oxygen here, right? Let's write that down. We got 6 oxygen here from this molecule. We got 4 oxygen there. Add those together, you get a grand total of 10 oxygen on the right. Oops. I went off the screen there, sorry. All right, so we got 10 here. In hydrogen, we have 8. 4 times 2 is 8. All right, so now we're going to put a 5 here, and that'll give us 10. All right, now how do I know it was a 5? Well, I knew I had 10 on the right. I got to have 10 on the left. So 10, I already have 2. 5 times 2 is 10. And that's how you figure that out. All right. Part 1, reactions with metals. In this experiment, we're going to throw some different types of metals in with some acid and see what happens. If the reaction is taking place, if the metal reacts with acid, you'll see bubbles forming. And those bubbles will actually be bubbles of hydrogen gas. And if we wanted to, which we don't, we could light the hydrogen on fire. Hydrogen is very flammable. We won't be doing that though, because, safety first. Part 2, reactions with aqueous solutions. Now, when reacting with aqueous solutions, we're looking for, generally speaking, solid formation. There could be heat as well, or the loss of heat. But in this particular part of the experiment, we're literally just looking for solid formation. And you can see here we have a clear liquid that is going into another clear liquid, and this brown sludgy solid is forming. That's a reaction. That's a chemical reaction. 2 clear liquids come together, give you a brown, red, green, whatever color, solid. That's an aqueous chemical reaction. Part 3, reactions with acids and bases. Fun experiment. We're going to be putting some acids in with some carbonates, and we're going to see what happens. Now, carbonate, or a common form of carbonate, or hydrogen carbonate, is sodium bicarbonate, or calcium carbonate. This is baking soda. This is eggshells. Very common to find them that. So, in this experiment, we're going to do some experimenting with carbonate, bicarbonate, baking soda, and we're going to see what happens. And you're going to do it too. Part 4, vinegar and baking soda. So this is an at-home experiment. You're going to get some cheap white vinegar from the store, some cheap baking powder, or sorry, not baking powder. Don't use baking powder. Use baking soda. You may already have these things at home. So if you do, don't buy anything. Just use some small amounts of what you already have. If you don't have any, go to the store, find the smallest box you can get and the smallest bottle you can get of each one. No need to spend a lot of money here. These ingredients are not very expensive and they're very common. My advice, do this experiment in your sink because it might overflow on you and make one heck of a mess on your countertop. Better to do it in the sink. That way you can wash it all down the drain. If you are sensitive to vinegar smells, strong smells like vinegar, you can do this reaction outside. Absolutely no problem. It's very benign to the environment. Just make sure if you're going to do it on your deck or anything like that, anything spills, just wash it off immediately. You should be fine. If it spills in the grass, just flood it with a little bit of water. Make sure it doesn't kill your grass. If you just rinse it. Your grass will be fine. But don't let it sit there. Eggshells. You can use a whole egg or you can just use eggshells. No, if you use a whole egg, you may not want to eat the egg afterwards, depending on whether the vinegar gets through the shell into the tasty egg portion. But you're going to put some eggshells in vinegar and see what happens. Make sure for all these experiments, you keep your nice old clothes on, nothing you don't mind ruining, and safety goggles. Protect those eyes. And finally, in part 6 of this experiment, you're going to do an experiment called GLIME or slime, depending on who you talk to. You're going to take Elmer's glue, borax, which is sold in the laundry aisle of your Mega Mart. It's just a laundry conditioner, very cheap. Don't buy a very big box unless you use it for your own laundry. Just buy a small box, as small as you can get, and try this experiment. This is really kind of fun. Now, for this experiment and for the vinegar and baking soda, you can add food coloring if you want. Some students in their videos for me to do this experiment have done some really cool things. They've thrown some glitter in it. They've thrown color into it, but in the form of food coloring. The baking soda and vinegar experiment, throw some red dye in there, some red food coloring. You got yourself a volcano in your sink, stuff like that. Just, make chemistry fun, because chemistry is an amazing science and it is a lot of fun. All right, guys, now with that, I want to wish you all good luck and good chemistry. We'll see you soon.